Welcome in next chapter of the counters operations. Here I show you some information about our first counter, which I will show you because we have got three of the counters. First counter, it is counter down, second counter up, and third counter up and down. Here it is a part from the easy book manual of the Siemens from the year of 2015, and I want to show you our first counter in this chapter. It is counter down. In a while I will show you exactly this in the program, but here in the manual it's much better shown how this counter works than in the help in the program of this block. So this block, as you see, has also some information about the variable type, and here have some information for these blocks. So CD, LD, PV, and outputs Q and CV. What it is exactly? CD, it is counter down signal. When we obtain this signal, it can be not only for rising or falling edge, because this block has this implemented, so it reacts first time on coming signal. Next it is load value, so here we put from which value it should be, sorry, not here because in preset value, here load, if here we put signal, then the value is this preset value. This is what I want to say you. Preset value, for example 20, from which the counting is started, is loaded to our counter by this load signal, and this signal is also Boolean signal. On output, the Q is in high position, so has the value of 1 if this counter is counted to the 0 value, so from 20 to 0 for example, and current value show which is exactly current value in this counter. How it works? We have got the operation as part of the chart. First thing, we have to load some parameter to our value, to our counter. Here we see that we put some signal on load. It is 0,1 signal, and this signal will load from our information in preset value, not CV. Here is some mistake. It should be PV, and this PV, the value 3, is loaded to our counter. When we switch off this signal, then this value on each signal of counting down is decremented by one up to the value 0. When we have got value 0, you see that our output of the counter is in high signal, like at the start, because this signal is equal to 1 when we have got counted value equal to the 0. And one more information, if we want to count it down, when we have got the value 0, it does not count lower than 0, and the output of this counter is still in high position. And last situation, when we have loaded signal, this for loading is still set on the value of the 1, then if we want to decrement value, it does not decrement, it still keep the value of the 3. So let's start programming. The counter operation in the program are in the folder of counter operations. As you see, the counter down, it is a middle counter. We can take it by drag and drop technology, and as you see here, we have to assign to this block some data block where these all parameters will be counted, because it is more complicated program. It's not adding, not subtracting, but some counting on different situations. Data block, so the name of our counter, for example, first counter down, because it will subtract by 1 the value. As you see, it can be counter of many variables. We use the integer. We have to put here the conditions which will counting down this value. So we can put our m0.0 in order to show you how it works. You can put here i0.0 if you have got simulator connected to the PLC directly by some switcher. In order to make it easier in my program, you can also make it. We can put here also one more parameter. In my from my side, it is exactly 100.5. You see that it is clock. I put this generator, which is implemented in the PLC. It was from our first chapters. If you don't know where it is exactly, so please see the chapter of the generators in order to see how to implement such a thing. You can have, of course, another part of the memory. This is exactly set it in device configuration. So checked, and for easier you can put also the same what I have. And here I put also some contactor which will load our parameter m0.1, for example. And we want put our value, and for example it will be constant value, it will be always 20. On the output we can, for example, switch some device, but we do not have it, or we can have. It can be, for example, output first Q0.0, and what else we have got counted value. We do not have to connect it to any parameter, but in order to see what we have got exactly now the value, we have to write something here. We use M0, so we can write MD1. I told you about this hole in the memories in the previous chapters. The first one after M0.0 and 0.1 is of course M0.2, but if we write some bigger area, we cannot start from the bits, we can start only from the bytes. So next 3 is exactly first byte, because it is M00, so it will go to M0.7, and first 3 is MD1. In order to have some multiplication of the two, we can start from MD2 in order to make it better. See that we have got here the problem, because we have got the integer and the output will be here, it should be double integer or real, something like this. So it is not MD but MW2. We see that if we make some mistake, the program will show it for us. And this everything we can load to the PLC. Sometimes we have to stop devices if our operation works and will change something in the program, so we have to accept it. And as you see, we have got our counter with data block which is connected to this counter. We have got our generator of 1 Hertz, so it is exactly by 1 second it will be working here, so decrementing the value. But you see that we have this condition not fulfilled and this value is not executed. As you see, the output of the counter is switched on because the counter has counted value 0. Because why? So next, because we does not load the value, preset value. So we have to start here, modify this value, and as you see, we have got counted value 20, and the output is switched off. In order to start counting down, we have to switch off load, because we put only once this loading. So the best thing, for example, here we should put here some trigger, for example slope on rising slope, and here we can switch it. As you see, after each second it is decremented to the lower value. when it is decremented to the value of the 0, then our output will be switched on because the counter counted 20 impulses of 1 second. So it is kind of timer, yes? Make it on counter down. As you see, this counted value is now minus values, but our output is still 0. When we start now also load value 20, we'll see that even if we want to count down this value, these values are still in 20. So it's not executed. So it is everything for the counting counter down. Only what I want to show you also for it is our data block. Our data block is created in system blocks because it is a system block for this counter. In program resources, we can see our first counter down, db1. When we click 2 times and we start monitoring here, you will see exactly the data block of this counter. As you see, here we have got counter up, counter down, reset, load, and some other parameters. Why we have got counter up? Because it is some main data block which also is used for other counters. So here we can see how it works, but it is not for us useful, so it because of this it is hidden in system blocks, but you know where it is created. This what we described to this counter. This value which we have got here, this current value, we can also use with comparators and make other operations. So it is everything for counter down operations.